Hello everyone, and here's the first part of my lecture series for integral calculus as an integral part of the curriculum for engineering and sciences programs. And on this video, I'll be discussing with you some basic integration formulas and anti-differentiation procedure. We first define anti-differentiation or integration as a process of finding the antiderivative or integral of a given function. And there are two types of integral. The first one is indefinite integral, which is written of the form integral of f of x dx, which is equal to capital F of x plus c, provided that the derivative of capital F of x plus c is equal to f of x dx. And we have an integral which is characterized by the limits of integration, and that is what we call the definite integral. And that is written of the form integral of f of x dx evaluated from a to b, which is equal to capital F of x evaluated from a to b, where a is the lower limit and b is the upper limit. And to evaluate, so what are you going to do is you just replace x by the upper limit and then minus replace x by the lower limit. And that is written of the form capital F of b minus capital F of a. And here are the four basic integration formulas. The first one, the integral of du is equal to u plus c. And with this, we can now deduce that the integral of dx is equal to x plus c. And similarly, the integral of dy is equal to y plus c. I sub 2, whenever there is a constant a, where a is element of real number, then the integral of a du is equal to a times the integral of du. And since the integral of du by I1, this is equal to a times u plus c. And then what you need to do is you introduce a each term inside. So you have au plus ac. And then you do not forget that a constant a times a constant t will lead you to another constant c. That's why the integral of a du is equal to au plus c. And then the third formula is the integral of sums, which is equal to the sum of their integrals. Written of the form integral of f sub 1 of u plus f sub 2 of u running until f sub n of u du is equal to the integral of f sub 1 of u du plus the integral of f sub 2 of u du running until the integral of f sub n of u du. And then the fourth one is the general power formula, which is written of the form integral of u to the n du, which is equal to u to the n plus 1 over n plus 1 plus c, where n is not equal to negative 1. When n is negative 1, we know that the denominator will become 0, and we do not want the denominator to be 0 because it will be undefined. Okay, so to illustrate, so we have example number 1, we wish to evaluate the integral of 5 dx. So what are you going to do is just to look on the pattern on our four basic integration formulas. Going back to our formula, so we have integral of 5 dx is similar to I sub 2, where a is equal to 5 and then du is represented by dx. So by I sub 2, there is a constant 5 here, so you can just throw it outside. Integral of dx, which is equal to 5x plus c. Example number 2. So we have integral of 5x dx. Modifying example number 1, I added x here. So you do the same. Okay. So we have integral of 5x dx. So there is a constant 5 there. So you can just throw it outside. 5x dx. So looking back on the formula, we can now use the general power formula of the form integral of u to the n du, which is equal to u to the n plus 1 over n plus 1 plus c. So in this case, your n is represented by 1. So you have 5x raised to 1 plus 1 over 1 plus 1 plus c. And therefore, we simplify this one. You have 5 over 1 plus 1 is 2. Then x 1 plus 1 is also equal to 2. So therefore, the integral of 5x dx is equal to 5 over 2 x squared plus c. Okay, we have this. And then for example number 3, we wish to simplify the integral of 1/2 x cubed dx. So again, there is a constant here. So we can write this of the form in 1/2 integral of x cubed dx. And then again, by power formula, we can write this as 1/2 okay, x raised to 4, that's 3 plus 1 over 4 plus c. And then to simplify, we have 1/2 times 1/4, that's 1/8, x to the 4 plus c. We can also use this whenever the power of x is a fraction, okay, of the form 2x raised to 2/3 dx. So applying the same procedure, so 2 can be written outside. So that's 2 integral of x raised to 2/3 dx. And that will lead us to 2 times x raised to 2/3 plus 1 over 2/3 plus 1 plus c. And then to simplify, we know that 2/3 plus 1 is equal to 5/3, leading us with 2 times x raised to 5/3 over 5/3 plus c. And then simplifying further, so you can just multiply 2 with the reciprocal of 5/3, and that's 2 times 3/5 x raised to 5/3 plus c. And then finally, that led us to 6 over 5 x raised to 5/3 plus c. Or you can employ this technique. So you have 2x, and then 2/3 plus 1 is 5/3. And then you just get the reciprocal of 5/3 and you write it in front. So that's 3/5. And then you add c. So finally, you have 2 times 3/5 is 6 over 5 x raised to 5/3 plus c. Say another one. Say we have integral of 7x raised to, say, 2/5 dx. Okay, one more. We have 7x, then 2 over 5 plus 1 is 7 over 5. Do you take the reciprocal of 7 over 5? Write it in front. That's 5 over 7. And then you add c. And then to simplify, 7 times 5 over 7 is simply 5x raised to 7 over 5 plus c. Another one. Say we have integral of 1 over 2x raised to 5 dx. Comparing this example with the rest of the example, with the rest of the previous example, you will observe that the constant, the variable x is written on the denominator. So what are we going to do is we just simply apply some laws of exponent. And then again, there is 1/2 here. So you can just throw it outside. Integral of, by taking the reciprocal of 1 over x raised to 5, so you can express it as x raised to -5 dx. And then you can now use the general power formula. So you have 1/2 x, then you add 1 to -5. So you have -4 over -4 plus c. And then you finally have -1 over 2 times 4 is 8. And then x is raised to the -4. So you can just write it on the denominator. So you have x raised to the 4th power and then plus c. And this is the integral of 1 over 2x raised to the 5th power dx. And then I'll just flush it here. Okay, then another example. Say you have the integral of 2x raised to 2/3 minus the square root of x plus 5x to the 4 minus 1 over x cubed dx. And then employing I sub 3, this is the integral of sum is equal to the sum of their integral. So you have 2, the integral of x raised to 2/3 dx minus the integral of x raised to 1/2 dx plus 5 integral of x to the 4 dx minus the integral of x raised to -3 dx. And then integrating the first term, so we have 2x raised to 5/3. You take the reciprocal of this, that's 3/5 plus c sub 1. For the second term, you do the same. 1/2 plus 1 is 3/2, so that's x raised to 3/2. And then you take the reciprocal of 3/2, that's 2/3, and then plus c2. And then for the third term, so you have 5x raised to 5 over 5 plus c3. And then for the last term, minus x raised to -2 over -2 plus c4. Then to simplify, you have here 2 times 3/5 is 6 over 5, x raised to 5/3, and then -2/3, x raised to 3/2, and then we have 5 over 5, that can be dropped off. So you have x raised to 5, then minus, this is another minus, so plus 1 over, and then since this is expressed with a negative power, I will just write it on the denominator, x squared, and then what will happen to the constant? So this is c1 plus c2 plus c3 plus c4, then I can write it as c. So we have this. 6 over 5 x raised to 5/3 minus 2/3 x raised to 3/2 plus x to the 5th power plus 1 over x squared plus 1 over 2x squared, and then plus c. Number 7, say we have the integral of 7x times the cube root of x to the 4 dx. We first simplify the integrand, okay? So by combining x and x raised to 4/3. And that will lead us to 7 integral of x raised to 7/3. That's x times x raised to 4/3. Then following the general power formula, 7 x raised to 7/3 plus 1, that's 10/3. And then you take the reciprocal of 10/3, that's 3/10. And then you add c. So you have this. Okay. And then 7 times 3/10 is 21/10, x raised to 10/3 plus c. And that is the integral of 7x times cube root of x to the 4 dx. Another one. So in this example, we have a product of x minus 4, x plus 3. Then simplifying, you can just multiply these two by applying the FOIL method. So you have integral of x minus 4 times x plus 3 dx is equal to x, the integral of x squared minus x minus 12 dx. And then by applying our basic integration formula, that will lead us to x cubed over 3 minus x squared over 2 minus 12x plus c. Next example. This time we have integral of x plus 3 to the second power dx. And then again, by employing some algebraic process, square of binomial. So you have the integral of x plus 3 squared dx can be written as square of the first, that's x squared. Then twice the product of the first and the second, that's 6x. Then square of the second, that is 9. And then we are now ready to integrate. So you have x cubed over 3 plus 6x squared over 2. So 6/2 is 3. Then plus 9x. Then plus c. So we have this. Then next example. So this time I raise it to the third power. Okay. So again, by employing the cube of binomial. So you have cube of the first. You have integral of cube of the first. That's x cubed. Plus thrice the square of the first and the second. So that's 3x squared. Okay. Times 3, that will become 9. Then plus thrice the product of the first and the square of the second. Square of the second is 9 times 3, that will become 27x plus then cube of the second plus 27 dx. And we have this. Then integrating, you have x to the 4/4 plus 9x cubed over 3 plus 27x squared over 2 plus 27x plus c. And then you have this. Okay. And then how far can you go? Okay. So say for example, I raise this to a very large power. In this case, that's to the 10th power. Integral of x plus 3 to the 10th power dx. Expanding this one, simplifying by binomial expansion, it will be very tedious and very lengthy solution. So what are we going to do is by change of variable, this is another technique or anti-differentiation procedure. So we call it by change of variable. So here, we will be calling out a variable, say u, to represent any expression on the integrand. So in this case, we only have x plus 3. Okay. And then differentiating this, you have du equals dx. And you got this. Okay. So by change of variable, we let u be equal to x plus 3. And then differentiating, so you have du equals dx, which means this can now be written as integral of x plus 3 is our u, then raise it to the 10th power. And then dx is represented by du. So that's u to the 10 du. And then integrating, so that will become u to the 11, that's 10 plus 1 over 11, and then plus c. And you got this. Okay. And then before you end up, you need to write it back to the original variable. So u is to be replaced by x plus 3. And then you have 1 over 11 times the quantity x plus 3 to the 11th power plus c. Another example. In this case, we wish to integrate y times the integral of 1 plus 2y squared dy. And then again, by change of variable, we shall now assume u to be equal to 1 plus 2y squared, because when we differentiate 1 plus 2y squared, its derivative can also be found inside the integrand. So differentiating, du is equal to 4y. That's the derivative of 1 plus 2y squared, and then you affix dy. So obviously, when you simplify this one, you got integral of the square root of 1 plus 2y squared. And then this y will go together to dy. So y dy, okay? And then you will observe here that this is 4y dy, and we don't want 4 here. So we don't need 4 on the right side. So we divide everything by 4, or we multiply it by 1/4, okay? Both sides of the equation. So that led us to 1/4 du equals y dy. And finally, okay, this can now be written as the integral of y times the square root of 1 plus 2y squared is equal to the integral of y dy is 1/4 du, this 1/4 du. Since 1/4 is constant, you can just write it outside the integral symbol. So y dy, that is represented by 1/4 du. And then the square root of 1 plus 2y squared is our square root of u. Then to simplify further, you can rewrite this of the form 1/4 integral of u. There's a square root, so raise it to 1/2, then du. Okay. And then to simplify further, or to integrate, we just use the general power formula. So we have 1/4, then u, 1/2 plus 1 is 3/2. You take the reciprocal of this, write it in front, 2/3, and then you add c, and then you got this. Okay, to simplify, you just multiply 1/4 and 2/3, and then replace u with the original variable, or express u to the original variable. So you have 1/4 times 2/3 is 1/6, then u is replaced by 1 plus 2y squared raised to 3/2 plus c. And then, okay, another one. Say integral of x cubed dx all over the square, all over x squared plus 4 raised to 3/2. So in this case, we have x cubed and x squared plus 4. So we might be choosing between these two, which will be our u. Again, when you choose your u, you have to make sure that its derivative can also be found on the integrand. So in this case, whenever u is x cubed, its derivative is 3x squared, which you cannot find it here. Whereas when x squared plus 4 is differentiated, its derivative is 2x dx. Okay, and which means you can rewrite this expression as the integral of x squared times x will go together to dx, and that give you x cubed dx. Okay, one more. X cubed is factored out as x squared times x all over x squared plus 4 raised to 3/2. So in this case, we can now let u, by change of variable, be equal to x squared plus 4. And then differentiating, you got du equals 2x dx. But then again, you only have x dx here. So we don't want 2 here. So we need to remove 2 here by multiplying this by 1/2 or dividing it by 2. Okay, so you have 1/2 du equals x dx. And then we are now ready to replace everything here. However, you need to look for an expression in terms of u to represent x squared. So from here, we can say that, okay, so the integral of x cubed dx all over x squared plus 4 raised to 3/2 can be written of this form. Okay, that's x squared times x dx all over x squared plus 4 raised to 3/2. And then again, x dx, this x dx is represented by 1/2 du. Again, there's constant. You can just throw it outside. So 1/2 du all over x squared plus 4 is our u, then raise it to the 3/2. And then next thing to do is to look for an expression that will represent x squared. And then from here, we can just say that x squared is equal to u minus 4. Okay, so we can now replace x squared by u minus 4. Okay, and then by employing distributive property of division over addition, this can be written of this form: 1/2, okay, times the integral of u raised to negative 1/2 minus 4u raised to negative 3/2 du. We just simply distribute u raised to 3/2 each term here. So that's u over u raised to 3/2 minus 4 u raised to negative 3/2. U over u raised to 3/2 will lead us to u raised to negative 1/2. Then minus 4 u raised to negative 3/2. And then integrating, you got 1/2 times u raised to negative 1/2 plus 1 is u raised to 1/2. Take the reciprocal of 1/2, write it in front, and that is 2. Minus 4, then u negative 3/2 plus 1 is negative 1/2. Take the reciprocal of negative 1/2, write it in front, and that is negative 2. And then the next thing you need to do is to introduce 1/2 each term inside the parentheses, and then you replace u by our x squared plus 4. So you have 1/2 times 2, that's 1. Then u raised to 1/2 is x squared plus 4 raised to 1/2. Okay? I have x squared plus 4 raised to 1/2 plus, okay, this is negative 4 times negative 2 is positive 8. That's positive 8 times 1/2 will lead us to positive 4. And since this is negative 1/2, you just simply write it on the denominator. So that's x squared plus 4 raised to 1/2, and then you add c at the end. Okay, and that's the integral of x cubed dx all over x squared plus 4 raised to 3/2. And then another one. This time, we have x to the fifth power times the quantity 2x cubed plus 1 square. Plus 1 squared dx. So similarly, by change of variable, we can say that u is equal to 2x cubed plus 1, and that du is 6x squared dx. And then again, this can be broken down as integral of x cubed times 2x cubed plus 1 square, and then x squared dx. So since this is x squared dx alone, so we don't need 6 here. So we divide everything by 6. So that's 1/6 du is equal to x squared dx. And then we have x to the integral of x to the 5, 2x cubed plus 1 squared dx can be written as integral of x cubed times 2x squared plus 1 squared, x squared dx. And then this x cubed can be obtained from here, which is equal to u minus 1 all over 2 equals x cubed. And then we are now ready to replace everything by our u, by u minus 1 over 2, and by 1/6 du. So we got this. Okay. X cubed is represented by u minus 1 all over 2. And then 2x cubed plus 1 squared is u squared. And then x squared dx is 1/6 du. And then to simplify, you can just throw this 1/2 up, 1/2 outside. So 1 over 6 times 1/2 is 1 over 12. And then you introduce u squared each term inside the parentheses. So you got this. 1 over 12 times the integral of u cubed minus u squared du. And then to integrate, so you have 1 over 12 times u to the 4 over 4 minus u cubed over 3, and then you add c. And then to simplify further, so what are you going to do is to factor out u cubed outside, okay? And then you get the LCD here. So you have this, okay? So we got 1 over 12, 4 and 3, the LCD is 12. And then you have 12 divided by 4 is 3 times u to the 4 is 3 u to the 4 minus 12 divided by 3 is 4 times u cubed, 4 u cubed. And then the next thing you need to do is to factor out u cubed. Okay, so we got u cubed here, and then you multiply 12 and 12. So they got 1 over 144 u cubed times 3u minus 4 plus c. And then the next thing you need to do is to write it back to the original variable. So you got 1 over 144 times u, which is 2x cubed plus 1 to the third power, times 3 times u, which is 2x cubed plus 1, okay? And then minus 4, and then you add c at the end. So you have this. And then to simplify, we got, you just simply multiply 3, each term inside. So you have 1 over 144 times 2x cubed plus 1 to the third power, times 3 times 2x cubed is 6x cubed, 3 times 1 is 3, minus 4 is negative 1, and then you add c at the end. Okay, and then we have this. So that's 1 over 144 times the quantity 2x cubed plus 1 to the third power times 6x cubed minus 1 plus c.